Good morning, year five. Okay, one more day until we've got a nice 3-day weekend. So, our learning objective today is estimating volume. Now, that is educated guessing. It's using what knowledge we know and what we've been given to have a good guess at what the answer might be. So, we've got a nice feedback starter from yesterday's PowerPoints. Hopefully, everybody will be able to have a go at that one. Just remember, 1 cube that we can see is equal to 1 centimeter cubed. Okay, so that is what we're looking at there. Very Fluency 1, the first one we're going to look at. Box A has a volume of 600 centimeters cubed. Estimate the volume of box B. So what we're saying is how many of box A can you fit into box B? Now, we don't know this, it's educated guess. So for me, I'm going to use lots of drawings on these shapes. For me, it's not very straight, but what I've just drawn on box B is about roughly the same as A. Again, roughly the same again. Can you see what I'm doing here? Roughly the same again. And the last one, oh, that fits perfectly. So I would say we've got roughly 1, 2, 3, 4 lots of box A that fit into box B. This is not the answer. Read the question again. Estimate the volume of box B. Box A has a volume of 600 centimeters cubed. Box B, we're saying that 4 lots are 600. What, 600 times 4? Just make sure your zeros look like zeros and not sixes like mine. Okay, so 600 times 4, that would give us a good estimation for number 1. Okay, now these are particularly tricky, so do give it your best shot to have a go, and they will come up in all hot and spicy, mega hot, and are you nuts. So let's have a little look. Shape A has a volume of 14 centimeters cubed. This is what we're given. So I'm going to put 14 cubed. Don't forget to put the cubed, that's our unit of measurement here, centimeters cubed. Estimate the volume of the other two shapes. Task number 1. Then which shape has the greatest volume? Now I'm going to break shape A up again, so roughly 1, 2, 3, 4 little sections we've got going on there. Now it's estimation, remember, so I'm going to start breaking up box B, shape B, certainly not a box that we know. So we've got 4 sections again here. I think this shaded section here is similar, not necessarily perfectly fitting, but similar to this bit over here that I'm shading. This shaded section here is similar, not perfect to this section over here. So that fits perfectly. And then what I would probably say is that these big tall sections here in B are, I don't know, maybe double the size, could be a little bit more than the sections here that I'm just put arrow in box A. So we know it's significantly bigger, at least double the size of these 2 big sections on A. So just off the top of my head, a logical guess might be that if A is 14, maybe this is around 18, 20, 22 centimeters cubed. So I'm going to go in the middle. 20 seems fairly logical to me. 3 cubed. Okay, and C. Let's start breaking this down. So we've got a really big long one at the top and 2 feet down the bottom. So what I think is that I'm going to use a different colour this time. Let's use purple, why not? I think that this arrow here, this section, and this section here are probably about similar to what I'm putting an arrow to box A. So it's probably similar to this section here again. Now, I'm going to use yellow for this. This big long section C is probably very similar to what's left over on A, because we've got quite a long section left over on A, including these 2 here. So maybe that fits around about the same. So remember, it's logical guesses. So I'm going to go with C being exactly the same or around the same volume as A. So I'm just going to pop in 14 centimeters cubed. And now let's answer the question, which shape has the greatest volume? I would say definitely B. Okay. have a little look with the answers there. Remember, we don't have to be perfectly spot on. We're just working this out roundabout. Okay, so estimate. Nice and quick one. These objects are ordered by volume. Complete the statement by estimating the volume of the other objects. Not to scale. Very important. Not to scale. Don't think about how big they are. All we're looking at here is logically, what's this? Maybe twice, 3 times the size. Something like so C is about 3 times the size of B. So I don't know. Let's go 3,600. It looks about that to me. I don't know what the answer is. 3,600, and A looks, I don't know, about a third of the size of B, so maybe 400, because 1,200 times 3 is 3,600. 1,200 divided by 3 is 400. Okay, so let's see what the answers say. That's my logical guess. Okay, so we were saying that A is a quarter of B, so we weren't too far away there, and C is 4 times as big as B, so I can totally understand that. I was a little bit off there, but still it was fairly logical in my guesses. So technically I got the answer to C incorrect, but it's not as though I was wrong, I just didn't quite marry it up perfectly. Okay, so do be lenient when you're marking your own work. Obviously if you're miles out, then don't give yourself the answer, but if you sort of see logical steps, then do be generous. Okay, so problem solving now. Stan is placing boxes on a shelf. Each box has a volume of 300 centimeters cubed. Now I'm going to do mine just normally. I can get another box in there, definitely. So on this row here, I've got 3 boxes. 300 times 3 is 900. And then C cubed is very hard when I'm trying to write. 900. Okay, the boxes aren't going to change size automatically. So the one underneath is going to be exactly the same. One underneath that is going to be exactly the same. One underneath that is going to be exactly the same. So we've got 3, 6, 9, 12 boxes on the shelf. Got 12 boxes on the shelf. You can do 12 times 300 or add it up as you go along. We know that one shelf is 900. So we've got another 900 underneath. Another 900 on the third one down. And on the bottom one, another 900 centimeters cubed. So then you can add those all up, see what you get. Don't forget the unit, centimeters cubed. Okay, yeah, so the answers are exactly what I've just said. Problem solving 2. Oh no, reasoning 1. Okay, this one's a really good question because you need to read what it says. I'm going to square or box cubes there for a minute. Matteo has estimated a number of cubes to make the next cuboid in the sequence A, B, C. He estimates that he'll need approximately 80 cubes. Is he correct? Explain why. With estimating, what we're really looking for you to be doing is getting onto the reasoning problem solving. If you can explain to me why you think your answer's right, I can give you the answer if you're not too far wrong. Without that, your answer could just look totally wrong. So get through the reason and the varied fluency, and then really work hard on reasoning and problem solving. Okay, we'll go back to this. Matteo's estimated number of cubes to make the next cuboid in the sentence. Now, we know that A is in fact a cuboid because it's not a cubed. So I've put that in half there. So we have 2 cubes that make up A. Now B, I would say, is maybe 3 times as big. If we think about 1, 2, 3. So maybe we say 3 times as big. Oh, that's 2. If it's 3 times greater than the size of A, and we've had 2 cubes in A, then I'm going to say that this is 6 cubes. Okay, now we look at C. C looks incredibly big. Let's work out how many B's we can get in here then. So I reckon if we go something like that, I think we could probably get around about 4 lots of B in here. So 1, 2, 3, 4. Now 4 lots of B would then make this 24. Okay, he estimates he'll need approximately 80 cubes to make the next sequence. Now I've times A by 3 to get 6, and then I've times B by 4. So I've gone wrong ever so slightly here, but it's an estimation. I need to be looking at, do I think B is 3 or 4 times bigger than C? I think B is 4 times bigger. So in this instance, I need to go back to A, because we need to keep to the same scale and sizing. And I think there's 2 cubes in A, so we're going to have to times A by 4 as well. So now, all of a sudden, we've got B equaling 8 cubes. And now we need to do 8 times 4, because we're keeping the same scaling. C is 32. And then to get D, the next sequence, we'd need to do 32 times 4. So I'd leave that for you to work out, but you should be able to see that that would be over 80 cubes. So I would say, through my estimations, and it's just my estimations, I would say no, he's not correct. Why is he not correct? Explain what I've just done. Now, I could be miles away from the answer. I'll show you the answer in a moment. I could be miles away from the answer. But if my explanation's good enough, and I'm thinking logically about this, then it's okay, because we can't see the shapes that well. Okay, so it's all about your explanation. So do be a little bit generous, and we'll be looking over this work anyway. Okay, let's have a look what the answers actually. Okay, so answer's incorrect. Exactly what I was thinking there. Originally, I had it down that A was 3 times bigger than B, and then I had to work out, do I think it's 3 or 4 times, because I thought B was 4 times bigger than C, and you've got to go with 1. You've got to go with 1 because we've got to keep the scaling exactly the same. Okay, sorry it's a really long video, but I do hope this helps. Happy Thursday.